Hello everyone and welcome to this video. We're going to discuss today atomic structure um, and we're going to see how that relates to things like the periodic table and look really at some of the fundamental ideas before we go on and study what we call the particle model and the standard model of physics, which is kind of one of the areas of modern research which we're really interested in. So let's start off with the image that you can see on the screen. You can see hopefully a very familiar picture, which is that of an atom. And we often draw atoms in this way. It kind of looks a little bit like the solar system. You have a nucleus, this central area, which is filled with protons and neutrons, and outside it, some electrons, which are orbiting, just like the planets would orbit around the sun. Now, just to be clear, this is kind of a model. It's an image that we have of the atom. It doesn't necessarily look like this, but it's a really useful model, and it's one of the better ideas that we have right now about how atoms work. So we're going to just discuss the things that make up atoms, and these are called our subatomic particles. And the first of those is the proton. Now, as you may be aware, we often say that protons are positive, and what that means is they have something called positive charge. And you can see that on the screen. You see this capital letter Q, that represents the charge. And for now, we're not going to worry about what charge is. It's all to do with electricity and coulombs, etc. We're not going to worry about that. What we're going to just say is that protons are positive, whatever that means, we'll kind of come to later. So Q is what we say plus E. E is what we call the electronic charge, and plus shows that it's opposite to negative, essentially, for now. Okay, we use this letter E because the electronic charge is actually quite a sort of a difficult number to write down, and it's much easier for us to write down E. In the same way, the mass of a proton is incredibly small, and it's much easier for us to represent as a U. So we often say that the relative charge of the proton is plus E or plus 1E, and the relative mass of a proton is plus 1U, where U here is the atomic mass unit. And again, these are numbers we'll get into later. What about a neutron? Well, neutrons are basically identical for all intents and purposes to protons, with the exception that they have a charge Q of 0. And so neutrons, as the name suggests, are neutral, and protons are positive. However, they basically have the same mass. Now, notice I say basically there. We might discover later that they're slightly different. That's not something we need to worry about right now. Now, electrons are the different bit. Okay, so you might want to take a second to think what electrons are. Would they have the same charge? Would they have different? Would they have the same mass? So feel free to pause the video at this stage. Let's have a think then. Electrons, well, as you may be aware, electrons are opposite to protons. And the way that we express this is they have minus E charge. They are negatively charged. And actually, that's what keeps the atom together. The electrons and the protons attract each other due to their opposite charges. Now, a big difference about the electrons is that they're incredibly small. They have a mass which is approximately a 2,000th of the mass of a proton. So if you're kind of trying to predict the mass of these things, we're taking the mass of a proton, whatever it is, dividing it by 2,000, and that represents the mass of our electrons. So electrons are incredibly small, just like small planets orbiting the more massive sun. Okay, now just a small bit of kind of nomenclature of terminology here. When we're talking about neutrons and protons, sometimes we call them nucleons, in the same way that you might have male students and female students, okay, which go to a school, which study. We have protons and neutrons, which live inside the nucleus, and so therefore we call them nucleons. Okay, they reside inside the nucleus, and our electrons exist outside. So this is our basic structure. We've got those nucleons inside the nucleus, surrounded by the electrons which are orbiting there. Now, why is this stuff all important? Well, it becomes important in terms of deciding what materials we're using. You may be familiar from your studies of chemistry about elements. And you can see an example here of an elemental symbol on the screen, which is that of copper. Now, copper has got two numbers associated with it. Now you'll notice down here, this is number 29, Okay, now 29 is what we call the atomic number of copper, and it tells us the number of protons in the nucleus. We're doing a little bit of chemistry here, but we're really going to delve a bit deeper into that, and so it's important that we get this sort of straight before we go further on. It turns out that the number of protons, the atomic number, identifies the element. In other words, every element has its own atomic number, its own Z. Okay, so different elements have different Zs, different numbers of protons. There is a number at the top there, 64, which in physics we might call the nucleon number. It is the number of nucleons which exist inside the nucleus, and it tells us the number of protons and neutrons which are existing inside the nucleus. Now, for this, we have got something important. That number 64 could change. It could be 65. And what that means is we would have the same number on the bottom, 29, but a different number on the top. That would mean the same number of protons, but a different number of neutrons. And hence, we would be having two versions of copper. We'd have two copper atoms, but with different numbers of neutrons. And what those are called are isotopes. Atoms which have got different A numbers, different nucleon, but the same Z are what we might call an isotope. I.e., we might have copper 64 and copper 65. They both have the same number of protons within their nucleus. And that's going to be important when we look at radioactive decay. Okay, so that's the basics so far. Let's kind of finish off by doing a quick question. Let's imagine we have this question. Here we have a symbol here which says 2210 neon is an atom of neon. And what we want to know is how many neutrons does it have? Okay, why don't you pause the video at this stage, have a go at the question, and then press play when you're ready to answer. So the key to answering this question is that we know A, which is the number of nucleons on the top there, and we know Z, which is the number of protons. Now, if we want to know the number of neutrons, well, we need to take the total number of nucleons, the total number of particles in the nucleus, and subtract the number of protons. In other words, the number of neutrons, N, is A take away Z, which means we've got 22 take away 10, which is 12. There are going to be 12 neutrons inside that atomic nucleus. Okay, as ever, feel free to sort of think about the ideas there, ask any questions, and if you think you're ready to move on, move on.